not first, Matt. Get your notes ready. We'll start in 1 minute. Alright, so write down objective. Today we're going to talk about 3D figures, solid geometry. So three-dimensional means you have length, width, and height in a cube, or x, y, and you have a z. It's like you have depth for every single thing that is there, basically. So if you look at this figure right here, you can see that it has different aspects, and today we're going to talk about how these solids are formed in general. So the first one I want to introduce to you is called a polyhedron. What does polyhedron remind you of? Like the word polyhedron. Type in the comments. What does it remind you of? Polygon. Polygon? Polygon? Polygon. Polygon. Polygon, right? So polyhedron is like a 3D polygon, okay? Three-dimensional polygon. It's a 3D detail borderline inappropriate. 3D figure with formed by polygons. There are many different ones, okay? If polygon has to be straight, right? It has to have straight sides. It's all good. This is a type of polyhedron, and there are different aspects of it, okay? You have a vertex, you have an edge, you have a face, okay? Now, can you tell me how many faces how many vertices, how many edges that this particular polyhedron has. Type in the comments once you're ready. Count number of faces, number of edge, number of vertices. Six faces, 8 vertices, and wait, what? Darren, I think you edges, right? So so does that change if you change the type of shape? Well, let's look at this. Different polyhedrons, okay? So if you look at this, there are two main types we're going to talk about today. One is called a prism, and one is called a pyramid. Prism is when you have the same base, top and bottom, or two on both ends. They have to be congruent in order to be a prism, okay? And the name of the prism is based on what shape you are, okay? For a triangle base, you get triangle prism. Rectangular prism means you have rectangles top and bottom, congruent, okay? Pentagonal, hexagonal. Pyramid is almost like a prism, except it only has one base. Okay, it only has one base. The top is converging to a point, which makes a vertex, okay? So same thing, your naming of a pyramid is based on triangle base, rectangular base, pentagonal base, and hexagonal base. Okay? So far so good? Now, Ryan, if you have circular base, then you change your name. But fundamentally, they're the same thing in terms of volume, area, all that stuff. But if you change it to circular, then we call it a cylinder and a cone. Okay? Now, let me ask you, first of all, you know, like the pyramid we found in ancient Egypt? What kind of pyramid is it, or are they? There are many, right? So how can I define those pyramids? What kind of pyramid is it that we most commonly see, even in the pictures or in the books, online, whatever? Which type of pyramids do you see the most often? Rectangular. You are correct. It has usually a square base, right? Usually a square base, and then it will be like that, right? So that's rectangular pyramid. Very good. Okay. So let's look at the next one. So we're in class that I figure. So instead of naming, because I want you to think about this, I want you to count. Okay, count number of vertices, edges, and instead of bases, just do faces. Okay. So can you name these two? What are these figures? And then after you do that, can you tell me how many faces, how many vertices, how many edges? Can you do that? So think faces should be 6, right? Because you have the base is the face as well, right? And then you get 1, 2, 3, 4, 5, 1 per each side. 6, 6, 10 is right, I think. It's all good. So what kind of what do we call this? Hexagonal or pentagonal? Which one is it? So you have to look at the base, right? What kind of shape is the base? Pentagonal, right? Pentagon. Pentagon means 5 sides. Penta, right? Pentakill. You with me? So pentagonal pyramid. Okay. What about the right side? What do we call this? Well, first of all, let's figure out the faces, vertices, and edges. Okay. Type it in once you get it. Five, 6, 9. Is that right? Oops. 5, 6, 9. Some people say triangular pyramid. Triangular prism. So it didn't put it upright. It doesn't have to be upright, right? Right now it has 2 ends, right? 2 bases of identical, congruent, and then they have the height, right? So this is a triangular prism. Prism, once again, has, I can't spell, triangular. Oh, somebody spelled it out. Thanks. Prism. Okay. Alright. So we have these patterns, right? Faces versus number of vertices, number of edges. So we're wondering if it gets some sort of pattern that we can follow for polyhedrons, okay? So in the past, long time ago, there's a guy named Euler. He developed a formula for this. Okay, well, this name is, it looks like it should be pronounced as Euler, but it's actually Euler. I pronounce like Euler. Okay. If you say Euler, people know that you're not real. Like you don't know the math people. You know, you gotta stay in the circle. You say Euler, that'd be, oh yeah, you're part of us. Got it? You gotta say Euler, okay? If you say Euler, people are like, oh, then they stop listening to what you said. Exactly. Euler? I'm not sure. Let me see what Euler is. It's German. One of the many German mathematicians. But he was a Swiss. Sorry. He was a Swiss mathematician, but the name Euler is German. Wow, Matt. Wow, Matt. I think he died in the Russian Empire in 1783 or something. Yeah. This is before the French Revolution. Anyhow, so what does Euler said? Euler says, if I'm a polyhedron, okay, then I have to follow this particular formula. F plus V minus E is always 2. Check if it's right. Look at this. 6 plus 6 is 12. 12 minus 10 is 2. There. 5 plus 9 is 11. 11 minus 9, 2. Look at the first one. 6 plus 8 is 14. 14 minus 12 is 2. It works, right? Isn't it interesting? Right? All right. So once you're okay with this, you can flip it over. So, have you seen these things before? These are called nets. Okay, nets are basically kind of like a 2D representation of a 3D figure. It's an expansion of it, right? Like this one is probably the most common one that you've seen, right? If you expand a box, like when you're younger, when you're trying to make a box, don't you try to make something like this and then cut it out, then fold it, right? So that's a net for a cube, or we call it a rectangular prism in this case, right? Or you can just call it a cube. Okay? Really good old days. I mean, you might have time to do it now, right? Just make a bunch of boxes. Alright. So, is a rectangular prism / cube a polyhedron? Because they say determine if it's a polyhedron, right? Is it a polyhedron? Yeah. Yes. Now, what's this? What is this form? So, you kind of need to use one of them as base, right? So, preferably, I think middle one could be base, and you fold these 3 up. Triangular pyramid? I can't spell pyramid. Okay. Is this a polyhedron? It is, right? We just talked about this. Okay. These two. What does these two make? What is this? This is a cone, right? This is the base, and this wraps around it, okay? Cone, this is a cylinder, right? These two are bases, and this is the side, lateral, right? Are these polyhedrons? Darren, you are correct. It would have to be marked as congruent to be a cube. Are these polyhedrons? are they formed by polygons? Right, this polyhedron by its name is formed by polygons, right? Are circles polygons? Are half circles polygons? Polygons have to be straight, right? So not polyhedron. Okay, not polyhedron. Well, yes, but no. It's actually no, Ditya. Alright, so last part, or not last part, second to the last part, we're going to look at a cross-section. Cross-section is fairly simple, is when you cut it, what does the cut section look like? Cross-section is like cut section, okay? So if you cut it from the point, obviously, then the cross-section will be a point, okay? If you cut it right in the middle of a cone, like this, then where you cut, when you open it up, it should look like two triangles, right? I mean, from the side, right? Because obviously there's half circle, but it should look like triangle, right? So the cross-section is triangle. Does that make sense? And if you cut horizontally, Aditya, it has to be multiple, I mean, it could be multiple polygons, but they have to be polygons in order to form a polyhedron. Okay, all of them has to be polygons. So like it can be formed by like for example, right? Like this one. This is a polyhedron because it's formed by 5 triangles and a pentagon. These are all polygons, right? But circles aren't polygons. Okay. All right, this cross section, if you cut it, the base would look like a pentagon, right? Pentagon. Okay, pentagon. Are we good? Understand what we're doing? Yeah, so cross section could be polygon or not. It depends on how you cut. Like if you cut it this cone slanted, then it will give you an ellipse, which is like an oval shape, right? So like it depends on how you cut it and that the shape. Okay. All right. Last thing I want to talk about is when you rotate things. Look, let's just say that I have a flag, kind of like a rectangular flag, I guess, like this. What will happen if I rotate this really, really fast? So when I rotate, the flag will rotate as well, right? What kind of solid would that form? What would that look like? If I rotate this really fast, like spin it. Wouldn't this side be rotated over? So basically your optical illusion will tell you that it's gonna make a image here, right? And then you're rotating, so the whole thing is gonna spin around, right? Right? And then use some of your art skills to make it happen, right? Let me and then when you spin it fast enough, it will look three-dimensional, right? All right. It's really easy. I never know how to do this until I knew how to do it. So I'm pretty sure you can also. So what if it's triangular? Like this. What will happen if it's triangular flag? And now I want to rotate this. So if you want to draw a rotation, this will keep you, this will be helpful all the way to calculus. So the way I draw is usually I would like to draw a reflection first. So reflection, okay, draw a reflection like this. That's a reflection, right? And I'm going to draw circles around it. So I draw a circle, like, oh, not a circle, but like an ellipse, but like 3D circle, right? And then you can start coloring if you want. So usually I just do one side and then do like, right? You just go, right? And then you do the side first, right? And then I'm pretty sure some of you are way better at this than me. And then you just, after you do the edge, and you just slowly do the other side. Don't overdo it though. You always want to start from the top because now the edge is always going to be darker than this side because you already drew it once, right? So no matter how you do it now, it's always going to have that gradient effect. Okay. Okay. I mean, you can all the way over here, but all right. Okay, we good with this. Understand what's going on in this section. This is pretty much it. There aren't a lot of things to worry about. So your homework and your test, right? Test is this week, remember? This is chapter 10 test. Okay, and then the homework, okay? Homework is 11.4. It's already on Big Ideas. Both of them are on Big Ideas, okay? BigIdeas.com. Okay? Homework is due Sunday. I think Sunday is it the 10th? Can't remember. Yeah, the 10th. The 10th. Okay, that's due. This has a different date. It's Friday, tomorrow, right? May 8th. It will be open at 7:20 a.m. and it goes all the way to 11:59 p.m., which means you have a whole day to do it. But the whole thing is about 20 questions, I think. So it shouldn't take you more than an hour, okay? 20 questions. But obviously you can use that as much time as you want. 20 questions. And just treat it like a usual test. You can open your notes, you can open your book in this one. But it's really simple. It's chapter 10 test. Because chapter 11 we're only halfway through. Kian. And then this one, the usual homework. This is also on Big Ideas. Any other questions? Last week of school, I think we were gonna have some sort of assessment, kind of like final, but I haven't decided what kind of format it's gonna be. So stay tuned for that. But we are planning on having some sort of activity on that week. Okay. Any other problems? Questions? Any other concerns? Oh, we haven't taken attendance yet. I remember now. Can we take attendance real quick? So if you're here, just say you're here. Oh, we can have a Zoom meeting any week. We don't have to do it like, but Hi, Alex. I don't see Logan. Anybody see Logan? Oh, Logan's here. Who am I missing? Is San here? Oh, San's here. Is that's it, I think. Everyone's here. Is Kina here? I don't see Kina. Kina, where are you? Anyway, Kina, if you're here later, send me an email. Okay. Other than that, let me see before we go. You haven't been resting, just Shida? Alright, so I'm missing Kina. And I think that's it. Indeed, quarantine isn't that fun at all. Alright, so that's it. So if you have any more questions, I'm here for another 1 or 2 minutes. If not, you're free to go. See ya. You guys can go back to sleep now.